Hello everyone, we are discussing multiplication of matrices. In the previous class, I have given the condition for two matrices to be multiplied. On what basis you can multiply two matrices? In all the scenarios, you can't multiply any two matrices. The only condition to multiply the two matrices is you can multiply if and only if A and B are any two matrices. If A is m by n order, B is n by p order, number of columns in first matrix must be equal to number of rows in the second matrix. Number of columns in the first matrix must be equal to number of rows in the second matrix. Then only you can multiply the two matrices. Then only AB product exists. AB product exists and its order will be m by p. First to last, m by p. Otherwise, you cannot multiply the matrices. If that condition is not satisfied, you cannot multiply the matrices. I explained how to multiply the matrices. You have to take row 1 in the first matrix. You have to multiply all the columns of the second matrix. After that, you have to take row 2. You have to multiply all the columns of the second matrix. Like that, you have to multiply. On this, let us do one example problem. Let us do one question on this multiplication. A is equal to matrix 0, 1, 2, 1, 2, 3, 2, 3, 4. That is A matrix. B matrix is equal to 1, minus 2, minus 1, 0, 2, minus 1. Find AB product and BA product. Find AB product and BA product. First of all, you need to check that condition. Number of rows, columns in the first matrix is equal to number of rows in the second matrix or not. That you have to check the condition. Then only you should start the multiplication. A order is 3 rows, 3 columns. B order is 3 rows, 2 columns. So here number of columns in the first matrix is equal to number of rows in the second matrix. So you can multiply A and B matrices. AB product exists. How to multiply AB product? You have to take row elements, first row elements, and here you have to take first column elements. Multiply the elements. 0 into 1, product of sum of product of the elements, individual elements. 0 into 1, that is 0. 1 into minus 1, that is minus 1. 2 into 2, that is 4. Next, first row into second column. You have to multiply all the columns of the second matrix by taking each row in the first matrix. If I multiply the second column, individual elements, 0 into minus 2, 0, plus 1 into 0, 0, plus 2 into minus 1, that is minus 2. Next, you have to take second row. Here I am rounding rows, here I am rounding columns, that you observe. Second row into first column, 1 into 1, 2 into minus 1, minus 2, 3 into 2, that is 6. Next, second row into second column, you have to multiply all the columns. If third column is there, you have to multiply the third column also. Second row into second column, 1 into minus 2, plus 2 into 0, plus 3 into minus 1. Next, take the third row. Third row into first column elements. 2 into 1, 2. 3 into minus 1, minus 3. 4 into 2, that is 8. Next, third row into second column. 2 into minus 2, minus 4. 3 into 0, 0. 4 into minus 1, minus 4. This is the product of AB, which is minus 1 plus 4 is 3. This is minus 2. 1 minus 2 plus 6, that is minus 1 plus 6, 5. Minus 2 minus 3, minus 5. 2 minus 3 minus 1 plus 8, that is 7. Minus 4 minus 4, that is minus 8. So here number of columns of the first matrix is matched with the number of rows in the second matrix. The resultant of the product is extreme orders. 3 by 2 matrix you have to get. 3 by 2 matrix. 3 rows, 2 columns. So AB product is defined. I'll check whether BA product exists or not. B to A product. So B to A product I am checking. B order I am checking. A order also I am checking. B order is 3 by 2. B order is 3 by 2. A order is 3 by 3. B order is 3 by 2. A order is 3 by 3. Here it is not matched. Number of columns in the first matrix is not equal to number of rows in the second matrix. Condition not satisfied. Condition not satisfied. Therefore, BA is not defined. You cannot multiply the matrices. You cannot multiply the matrices. So, this is the process of multiplying matrices. You have to take rows in the first matrix. You have to multiply all the columns of the second matrix. And condition for multiplication is number of columns in the first matrix should be equal to number of rows in the second matrix. Next, matrix multiplication is not commutative, means it will not satisfy commutative property. Commutative property means whatever operation between A and B is done, that must be equal to same operation between B and A. Commutative property under addition is A plus B equal to B plus A. Commutative property under multiplication is AB equal to BA. AB equal to BA. In general, it will not be satisfied. In general, commutative property will not be satisfied in case of matrix multiplication. In case of matrix multiplication. Because in the previous case itself, we have observed AB existed, BA does not exist. In general, real numbers commutative property will be satisfied. If I multiply 3 and 5, that will be equal to 5 and 3 in case of real numbers. Always it is satisfied. But in case of matrices, AB, BA may not be same. May not be equal. Sometimes AB will be defined, BA may not defined. If AB may not define, BA may defined. Both defined, AB may not be equal to BA. So, in general, matrix multiplication is not commutative. This is point number 1. Note, important note. In general, matrix multiplication is not commutative. Matrix multiplication is not commutative. In general, AB is not equal to BA. In general, AB is not equal to BA in general. Sometimes it may happen. Sometimes they may be equal. Sometimes they may be equal. Second point, in real numbers case, if 3x equal to 3y, you can cancel 3, then it becomes x equal to y. But in case of matrices, it may not be equal to true. If AB equal to AC, we can't say AA cancelling, we can't say B equal to C. Even though B and C are different matrices, you may get the same product. You may get AB product matrix is equal to AC product matrix you may get. It will not be applied like real numbers. We can't say B equal to C. This is one more important thing. Third one, associative property will be always satisfied. What is associative property? Three things will be there. In different orders, we will multiply AB into C, that is one order, A into BC, that is second order. Both the products will be same. That is true in real numbers case as well as matrices case also. If ABC are three matrices multiplied, ABC are three matrices. If the product exists, AB product exists, and if it can be multiplied with C, then it will be equal to A into BC product. ABC are three products. Matrix multiplication is always associative. Always we can say AB into C is equal to A into BC. Associative property will be satisfied, but commutative property will not be satisfied. Cancellation law also it will not apply. Both sides AA if you cancel, B equal to C you can't say like real numbers. Fourth point is AB equal to BA becomes true, always true. It is a point against to first point. In general, it is not commutative. When it will become commutative? Case I am writing. AB equal to BA always true if and only if A and B are diagonal matrices. A and B are diagonal matrices. If they are diagonal matrices, then commutative law will be always true. AB product will be equal to BA product. Diagonal matrix means already I explained. Only diagonal elements exist, non-zero real numbers. Remaining all elements will be zeros. That type of matrix is called diagonal matrix. So in that case, AB will become equal to BA. In remaining matrices case, it may not be true. So always that property will not be applied, but associative property is always true. To multiply any two matrices, learn the condition. That condition is important. How to multiply the matrices, it is very important. You have to take the rows in the first matrices and you have to multiply all the columns of the second matrices. And resultant product order also you must be able to note. You must be able to find. So these things are important while dealing with matrices multiplication. And important notes also I have given. Matrix multiplication is always not commutative. It will become commutative in case of diagonal matrices. Cancellation law will not be applied. It is not true. You can't cancel A, you can't say B and C matrices are same. And matrix multiplication is always associative. It satisfies always associative. So these are the things about matrix multiplication. Practice some more questions on matrix multiplications. We'll meet in the next class. Thank you.